Good morning, everyone. So, today we will be learning intermolecular forces. Remember, from the kinetic molecular theory, the molecules are in random motion. The molecules interact through attractions or repulsions. That means they have potential energy. So today you are going to learn intermolecular forces and how do they affect the physical properties of substances. You are going to learn more than that. The role of intermolecular forces, the role of hydrogen bonding in our life. And I'm going to show you a 2-minute video at the end, so you'll understand how important the intermolecular forces are, especially the hydrogen bonding. So are you ready? Yes? Okay, so let's. So what are the intermolecular forces? And how do they affect the physical properties of matter? Physical properties like boiling point, melting point, states. What are the 3 different states? Matter can exist in solid, liquid, and gas. Also the vapor pressure. So remember from chapter 5, you have to determine, first thing, you have to know how to determine the polarity of a molecule. And you have learned that. That's right? How to determine, that would be the first step. Before finding out what type of interactions are present, you must know whether the molecules are polar or non-polar. So let's see, one question. Can you answer this? Which of the following molecules are polar? And we have discussed these molecules many, many times. These are very, very common. Ammonia, methane, water, carbon dioxide. A, 1, 2, and 4. B, 1 and 3. C, 1, 3, and 4. D, 3 only, or all of them. You have 30 seconds. So most of you answered 1 and 3, and that is correct. So we know how to determine the polarity of molecules. We learned that ammonia is polar, water is polar, methane is non-polar, carbon dioxide is also non-polar. Now, can you tell what would be their relative boiling points, or what would be their states, just by knowing the polarity of the molecule? Can you predict, for example here, can you predict which of the following compounds has the highest boiling point? So just the polarity would be the starting point, but that's not enough. You have to know more than that. You have to know what type of intermolecular forces are present within these molecules. So in order to know that, how many and what type of intermolecular forces are present, that's very important. To find out their physical properties, their boiling point, their melting point, their state, whether they will be in the gaseous state, liquid state, or in the solid state. There are many, many questions here. You know, there are some of the things are solid, some of the things are liquid, some of the things are gases at room temperature. Why? You know that some of the things can be dissolved in water. You can dissolve sugar in water, but you cannot dissolve sand in water. Why? You know how medicines work in our body? Do you know that? When you take a medication, you can take by mouth or by intravenous injections. So if you take, for example, by mouth, what happens first? It has to dissolve in our stomach. That's right? So to dissolve, it has to have intermolecular forces. You have to know what type of attractions can dissolve them. All about intermolecular forces. So you have to know what are the forces present in the molecules to find out how things work. You know, oil and water do not mix, but do you know why? They don't like each other. You know, some of the things, the metallic things conduct electricity. Non-metals are brittle. And all of the answers have to do with the intermolecular forces. So this is very, very important to understand. So the intermolecular forces are the force that brings things together. The intermolecular forces are the force that is in, we cannot see them. We cannot see the molecules. You know, if you open your eyes, we see sometimes to see you have to open your eyes. But in chemistry, some of the things, you have to close your eyes to see through the experiment, to see through the knowledge, how the molecules interact. So this is very, very important, intermolecular forces. Now, before going to understand intermolecular forces, you have to know two terminology, intra versus intermolecular. Intra means within the molecule, and we have learned those, the bonds, covalent bonds, ionic bonds. They are the intramolecular forces. For example, I have a molecule here, so there are bonds. So there are forces between in the molecule. They are very, very strong. Now, if I have two identical molecules, so they will interact with each other by intermolecular forces. So the inter means between the molecules. Intra means within the molecule. So here, for example, I have a pentane. So when you boil the pentyl, so in liquid state, there are forces between the molecules that brings the molecules together. That's why they are in the liquid state. But when they are in the vapor state, then there are no force between the molecules. So there is no intermolecular forces. But here, because of the intermolecular forces, they are in the liquid state. But this is very important. You need to know the London forces are the weakest among all the different forces, intermolecular forces present. So the London forces, then dipole-dipole, then hydrogen bond. Hydrogen bonding about 10 times stronger than dipole-dipole. Then we're going to discuss other two forces. So our focus today is to learn the intermolecular forces. These are called also van der Waals forces. Molecule. Is it polar or non-polar? Non-polar, that's right. So this is a non-polar because two identical hydrogen atoms are present. So there is no electronegativity difference between these two. Equal sharing of electron. Equal sharing of electron means non-polar. But from the kinetic molecular theory, you learn that molecules are in motion. So do the electrons. And when the electrons are in motion, so the electrons can move temporarily from one hydrogen to another hydrogen. One analogy can be given, very simple, and this is applicable for everything, every substance. Let's see if you have a bucket filled with water. If you move the bucket, what happens? It's going to slosh from side to side, that's right? The same thing, whenever you have electrons, electrons are in motion, so they can slosh. As a result, there will be a temporary dipole. Again, very, very important, that is temporary phenomenon. Hydrogen. Now, if you look at hydrogen and compare with other non-polar molecules, like we discussed, methane. Methane is much bigger. That means it has higher molar mass. It has more electrons. So the more electron, now think about the bucket analogy. So if you have more water, it is going to slosh even more because you have more water. When you want to move the water bucket, it is going to slosh even more. So here the attraction is going to be more. So higher the molar mass, we can predict we will have more London forces, greater London forces. So the boiling point ought to increase because of the greater London forces. So higher the molar mass means greater the London forces means higher the boiling point. You don't have to worry about all the numbers I'm talking about. We are not interested to know what is the actual boiling point or melting point. But from the boiling point and melting point, you can feel how strong the attractions are. Boiling point means what? Whenever we talk about boiling points of these, for example, propane. So the boiling point means there are attractions between the molecules. You are going to put heat energy to separate the molecules. The stronger the attraction means you have to put more heat in. So more heat is required to separate the molecules if the attractions are stronger. So that's why the boiling point goes up. Because boiling point means the molecules has to go from the liquid state to the vapor state. So the molecules have to be separated. But if there are strong attraction, then you have to heat even more. That's why. So we are not interested in exact number, but you should be, by looking at the formulas, by looking at the structure, you should be able to analyze which one is going to have higher boiling point, which one is going to have lower boiling. That is your goal. If you look at the periodic table, group 7. Group 7, what are the family name? The family name? Halogen, very good. Halogen. So halogens are in group 7. And you know, all the diatomic molecules, they are non-polar because there is no charge separation. Two identical atoms are together. Now if you look at fluorine, chlorine, they are gases. Fluorine, chlorine. Bromine is liquid, iodine is solid. How do we explain? So higher the molar mass means stronger the London forces, means the boiling point would be higher. So the physical state also you can guess by looking at the structure, the size. You can guess the boiling point and the physical states. So can you tell which would you expect to have the higher melting point? C8H18 or C4H10? Very good. Most of you got right. It depends. If you compare with the comparable size, then of course the dipole-dipole is going to be the dominating force. If one is too large compared to the other, then large means it will have higher London forces, greater London forces, higher boiling point. So that's you need to. So far we learned only London forces and the dipole-dipole. By comparing these two, can you tell which one has the lowest boiling point? Here also we have oxygen and hydrogen, but no hydrogen is connected to this oxygen. Hydrogen must be attached to oxygen, nitrogen, and fluorine. So if you compare these two, which one can form hydrogen bond? The hydrogen bonding can be present only if you see this kind of linkage. So the linkage must be oxygen, hydrogen, nitrogen, hydrogen, or fluorine, hydrogen. If you see any of the linkage in the molecule, then you know the molecule is capable of forming hydrogen bond. That is very important. If the oxygen is present itself without any hydrogen attached to it, that cannot form hydrogen bond. That can have only dipole-dipole interactions. Water. Water is very important for life. We learn the water has a special structure. What is the shape of the water? Mickey Mouse. That's right. So here water. Water has a dipole, permanent dipole, very important. So this is how water molecules form hydrogen bond. And it's a special kind of dipole-dipole interactions. Because of this type of bond, water has many, many unique properties. So we're going to discuss. Very good. So most of you got it right. So that's the molecule. It can form hydrogen bond because hydrogen is attached to one oxygen here. So that can form. So now we're going to understand the importance of hydrogen bonding in our life. The importance of hydrogen bonding. It's a hydrogen bonding plays a vital role in biological system. You know what is our identity? The DNA. You'll be learning more about the DNA. How DNA can transmit a secret language to form different types of proteins. Without the hydrogen bonding, DNA won't exist. The helical structure, double helix, two helix are connected together by hydrogen bonding. So the hydrogen bonding plays immense role in biological system. 83% of our blood is water. Each day we consume more than 2 liters of water. Water has unique properties, unique qualities because of the hydrogen bonds. So the water is very important, is essential for life to exist on the earth. Water, without the hydrogen bonding, life cannot exist on earth. Very, very important. Polarity contributes a role, but hydrogen bonds plays a major role for the life to exist on the earth. We are going to continue the next 2 chapters on the water. Chapter 9 also water, solution, chapter 10. So what is the importance of the hydrogen bonding in water? Hydrogen bonding. Okay, that's all for today.